Hey, I'm Joe Burnett, and I would like to show you GitLab Steps for Duo Workflow. So I've been trying out Duo Workflow, and I needed a place to do it, so I decided to try out GitLab Workspaces at the same time. So Workspaces is like the web IDE, except it's actually running on a VM. So I spun up a workspace, and you can see here, I actually have a real command line prompt. It's a real Linux machine. It's just you running VS Code remotely. And then GitLab Duo Workflow, this web view is built into the plugin for VS Code. And so I was able to get it working with a SSH tunnel workaround. We're working on getting the thing working natively, but with a little effort, I was able to get it working. And I was able to use Duo Workflow to try to solve some issues. So the first thing that I did, I grabbed like 7 random issues from the GitLab runner repository and just threw them out there. I actually used like 4 workspaces at a time, which was pretty cool. And I said, solve this, like deal with this. And it went okay. It wasn't super great. It wrote some code, right? It wrote some code. There was some confusion, a lot of clarification, some redirects. I had to sort of reset a little couple times. And I learned a little bit about what it's like to work with AI. I can't just throw something over the fence. Um, the AI wasn't able to say that I don't know what I'm doing. Like something's wrong here. I'm going about this the wrong way. That's actually something that it can't really do, as far as I can tell. It can't step outside the context that it has. That's something that we can do as humans. We're good at like being like, hey, this is not working. So I tried something different with this demo. I built something and I want to show it to you. And what I did while I was building it was kind of went back and forth between the AI. I was like, hey, here's a chunk of code, that you can put together. It did it fast, one straight sprint. Then I kind of redirected it and I was like, okay, now write, kind of like an example, set things up really nicely, and then you could do the next sprint. So I was like back and forth, back with workflows, and with me sort of setting the context and spending a little bit more time giving it a very clear and straight path. And it got a lot done really fast. It was really pretty cool. So here's what I built. Okay. I wanted to give steps to do a workflow. Now, if you don't know what steps are, they're little reusable chunks of code. They're originally built for a CI. They're reusable. You call them with inputs and outputs. They can exec things. They can call other steps. So you can have a whole graph. They can do it from your local repository, or you could do it from a remote repository. So you can depend on other projects. And they can also bring files with them. So you can have payloads like scripts or whatever it is that you need to bring with the step. Um, Now they're tools, right? Like these are just like little specialized tools. And I wanted to see what would happen if I gave these to do a workflow. But I didn't really want to set up like the whole development environment because I don't know, I've never done it. And I just wanted to get to the good part. So I kind of took a little shortcut. And I just made an agent here in my workspace and gave it an Anthropic key so it could talk directly to Claude. But it's basically the same thing that Duo Workflow does. So like you can, because Duo Workflow uses Claude under the hood, right? Okay, so the first thing that I did is I took Thorsten Ball's article about how to build an agent, and I gave it to the AI and said, implement this. Fast forward me to the end where I have working code, which is exactly what Thorsten asked us not to do. And I'm very sorry about that. But we're going to have an aha moment later. So it's okay. The next thing that I did was I took Step Runner and connected it to this agent. So this environment here, I've got my shell, but I have another shell over here, which is running Step Runner. You can see Step Runner's Golang binary. It lives in CI, right? And the job is given to it as a payload and it drives through these steps, but it can also be brought locally, right? Like I can run it on my workspace, I can run it on my laptop, and it does the same thing. It's just a gRPC payload instead of having like this whole like shell script environment thing. So it's about taking CI, making it work locally, making it work predictably in the same way, try to make things consistent, decoupled, and portable. Um, yeah, so I connected it there, and then I made a method for listing steps and running steps. And I told it to actually, I told the AI, now, okay, please uh, wire this in. Okay, so I've got like a little steps folder here where I create a runner, and I gave it a couple methods, right? Run step and list step, and had the agent do that. I had to do a workflow, like the real dual workflow, do the real work of wiring it into my agent, right? And actually like providing the first class tools. So as you can see here, I've taken away the tools the agent had before, which is reading, listing, editing. And I just gave it a little bit of a redirect. I was like, okay, you can list steps from this local repository and you can run them. Those are your two tools. All right. So I was kind of curious, can it actually use these? The answer is yes. And I'm going to show it to you. It's pretty cool. Okay. So yeah, we have step runner running locally. All right. And we have some code that works. And let me show it to you. All right. So go run. Here's my agent. The agent just kind of lists the files or the local steps. I'm going to say, okay, one of the things that happened to me with running dual workflow earlier is like, because it couldn't actually run anything, it couldn't update my Go deps. So I had to keep cleaning up after it, which was kind of annoying, right? Like I kind of wanted it to like finish something. So I gave it a tool called Go Mod Tidy. And I notice the agent that only provides the steps that are defined in this local repository, right? It's like the repository comes with the tools to work on it. That's the expectation. But it actually under the hood is using a remote step. Now, this can still be constrained by policies because the step runner knows about the whole execution graph, but it allows you to bring things in a curated way. So I'm going to try to get it to run this. Okay, please update my Go mod files by running Go mod tidy. All right, let's see what it does with this. So first thing it's doing is listing steps. Let me check. Okay, blah, blah, blah. It's running a step, Go mod tidy, and bam. And it gives us a summary of what it did. Yeah, and you can see that these Go mod files are no longer telling me errors, which is super duper great. Things are cleaned up. All right. Okay, let's take it up to the next level. I wrote a test. As I was saying, all the tools are defined in the repository. The agent has access to the repository. I don't want the agent to edit anything in steps. So I would like to modify the editing step to prevent any edits in the step directory. So I wrote a test to verify that, which fails. So if you come over here, and if I say go test repository's current state, there's a failing test. Okay. Doesn't actually really say much about why, but you can figure it out. A human can figure it out by reading the code, right? And the comments. So let's see if an AI can figure it out. Okay. There is a failing test in my project. Please run the tests, find which one, read the files, and fix the implementation. All right, let's see what it can do. Okay, blah, blah, blah. Oh, yeah. It gives me a little summary too. Okay, so I ran it. It lists in the files. It's reading main test. It's reading main go. I noticed, if I give it like a plan, it seems to how to do a lot better. The more ambiguous I am, the more it sort of thrashes around. This is probably why Duo Workflow has the structure that it does. It made an edit to my file, and now the test passes. That's pretty cool. And it gives me a little summary of what it did. Hey, look at that. Let's go look at it ourselves. All right. Git diff. Okay, so it did all the Go mod stuff. And then it added this little bit here, which is pretty obvious, but it was able to figure it out. I said, test fails, go see if you can figure it out. Of course, we should have good test failure messages, right? For the humans and for the AI. So I think it's really important for us to think about how we make AI inclusive, like how we bring AI into our workspace. I think that it should be part of our code review, part of our process. And not only does it have unit tests, but these are tests that an AI can work on, which is good for the humans too, right? But we're kind of used to taking advantage of this higher level context switching ability. We're used to using too much of the various tools that humans have that are way more limited in their resources. Like we don't have as many of them. Um, so a code change should be something, the code base needs to be something that AI can actually engage with and work on, which means that some of the really weird stuff that we got going on in GitLab Runner probably doesn't pass that bar, which means the only person that can work on it is a human, which sucks, right? So if it's not AI inclusive, you're going to pay for it with human blood. Okay, so it fixed the problem for us. That's super cool. I'm going to show you something else here. I'm going to drop out of this and I would like to show you step results. So there's a file here called step results that my agent wrote as soon as I closed out the conversation. And what it is it's a detailed trace of everything that the AI did, all the way down, right, through the whole execution graph, inputs, outputs, environment variables, everything, version of code used, remote, local, all the way down to the exec that was run to make this thing happen. You can see that there's 7. It did 7 things. Let's take a look at them. And I'll tell you why this is important. Okay. So the first thing that it did was it ran. This is kind of verbose, I know, but it's just the way that it works. It ran a remote step, right? Hello, Go stuff. Random repository I made for this demo. I ran the tidy step in that file, version 1. That's good to know, right? And the sub step, right? So it actually recorded what that step did too. As an exec, it actually ran go mod tidy. Not a big surprise, right? That's exactly what we were expecting. Okay. Let's take a look at the second to last one. This one's interesting because this is where the AI actually fixed the problems. Now notice what the inputs are here. The inputs are exactly the same as what you would get from what you would put into edit file here. So this is what a step definition looks like, right? It's got this top part here, which is the spec, and you give it a path, an old string, and a new string. This is the same thing that previous tool did, but a system step form. And then it has a second document here, which is the implementation. So it's like the signature and the body of the function. The only thing that the AI gets is the signature. That's the only thing it needs, right? It just needs to be able to call and see what the outputs are. So for example, list files has outputs, which is an array of files, okay? So in edit file, we have these inputs. We can have defaults. We can use expressions. This is all part of steps. And then under the hood, what actually happened here was it actually execed something. You go run internal files. What is all this? Now the inputs are as a JSON string. The actual implementation of these steps that I provided is here in this Go file, right? It could be a shell script. It could be a binary, right? It could just like actually really what we want to do with Go files is compile them and distribute them in OCI images along with the step definitions. It doesn't really matter actually because it's inside the function. It's the implementation details. So yeah, so we edited this file, and this is the big string with search and match that and replace that fixed the thing. And then finally, we ran this to verify that tests actually work. Go test run again. So the point is, we can capture an exact trace of what happened. This is useful because as we start using bits and pieces of code from all over the place, we solve one problem, which is reusability, and we bring on another, which is supply chain dependencies. How do we make sure that none of these are changing and bringing in something that we don't want? And so it's really important that we also have checks on the versions, right? And so what you could do here is you can run this and you can capture exactly what version each tag applied to, and you can get a checksum, just like you have go mod, right? And you have go sum. You can get the sum file for your workflow, for your CI workflow, capture all the dependencies that should be coming with this version of your code. And every time you run it, you pass that sum file and the step runner will enforce it. So if someone tries to move a tag to a new commit, step runner will stop and say, that doesn't match my checksum file. I'm not going to execute this code. So running everything through the step runner also gives us a slice of the control plane that allows us to enforce supply chain security. It also lets us enforce policy. Like imagine that as an organization, you want to say the only steps that you can run are ones that are in these repositories. Or maybe you want to say you can only run steps that have a signed certificate or whatever of like, their SBOM, some constraint, right? That you can tell based on the payload. That policy can come down and be enforced by step runner too, right? And so there's not a way to get around that because it's all being driven through the same interface. That same capability in CI can apply to AI, right? Like if I have an AI running things in my workspace, I can tell you exactly what was done to produce that. Maybe it does the whole thing by itself. It can come with proof of what it did, right? That is not something that it controls because it's the step runner itself. Also, I can't allow the AI won't be able to use any tools that violate the policy of the organization because again, driven through step runner. But I think more importantly, the big point is that in CI, we need simple tools that are composable and understandable. And in AI, we need tools. And as developers, we need tools. It's all the same thing, right? I want to break down these barriers so that it's all the same tool. And that lowers the impedance mismatch for these kinds of handoffs. Where I can say to the AI, hey, this test is not passing. Can you look at this and try to fix this, right? The same things that I do in my local development, I should be able to ask the AI to do and vice versa. The same thing that I do in CI, I should be able to do right here locally on my machine. I should be able to use steps to set up all the services and run my CI job more or less exactly the same way that happens in CI. I should be able to use my workspace and I should be able to use it to connect to and debug CI jobs, right? As long as we're using the same interface, as long as we make these things interoperable, we get compounding benefits, right? You can use a step from the CI catalog in your job, in your development, the AI can use it, right? Like you can share these things and the mechanisms for monitoring them and in controlling them also are common. For example, these same step results, these are going to come back into the GitLab database. And as a step owner, I'm going to be able to say, who is using this code, right? Who's using my step? What version? How is it performing, right? So like an AI should be able to plug into that too, right? Like we should be able to have a sense of what tools are useful for AIs, which ones they're using most often. All that's possible as long as we have an interface. So I think GitLab Steps for Duo workflow is something that can be pretty powerful for the way that it puts an interface on something. So yeah, thanks for watching my demo and my spiel. I hope it gives you something to think about.